How often have we heard that Indian politics is driven by money and muscle power? As a statistician, our objective is to see that if a statement like that is made, is there a way to be able to see how true that statement is? Can we form appropriate hypothesis which can actually check that having money or having crime record helps in winning an election? In this simple exercise using regression, we will take data of a particular state, a particular type of election. We will look at all kinds of candidates who had fought in the elections and find out, is it the case really that being rich or having criminal records pays? That is it more likely that you are going to win the election if you have a criminal record or you are the richest candidate in the constituency? To do that, we will use a simple technique called the regression technique. We will use the data of the West Bengal Assembly election, we'll code the data, we'll form the appropriate hypothesis, and then we will prove the statement whether crime and money pays in elections in India. Now let us try and see how does one actually perform a regression. Look at the variables, identify the variables which you're going to estimate, identify the variables which you think are going to help you estimate, and then finally end up with interpreting the results. So what I'm going to do is I'm going to use a kind of data for which you don't need to know much of the theory behind it. You are probably aware of the scenario which helps you in formulating a particular hypothesis. And given that structure, I'm only going to look at how does one do the regression. So this is a data which we're using, an election data. As you can see, this is the assembly election for West Bengal conducted in the year 2011. And what I have right now is data of about 1700 candidates. So 1700 minus 1, 1699 candidates, all of whom had fought the assembly elections in West Bengal in the year 2011. Now the data I have got from the Election Commission website. You can actually download the data yourself and also do some more additional testing apart from what I am suggesting here. So here is how the data is stacked. You have years, you have the state, which is West Bengal, the districts, you have the account names, and then you might be aware that some of the constituencies in all over India are reserved for certain categories, and some of the candidates are open to all categories. You have the candidate name, you have the gender, age, the party, the total number of electors. This is the total number of people who came up. The 86.23% is nothing but this divided by this. This is the number of votes this particular candidate has gone. Okay, this is the percentage vote share of this particular candidate. This is the status. Clearly, somebody who got 0.69% had his deposit forfeited. The person who won from this constituency got 46% of the votes. The person who was the runner-up from this constituency got 42.1% vote, and the rest have got the remainder of the votes. Now, when candidates file for elections, they have to, file an affidavit where they have to declare certain activities. For example, they have to declare they have a PAN number or not. They have to declare whether they have a criminal case or not. Okay. In some cases, you might get even a fine-grained information about the criminal cases, in the sense that how serious are the crimes, under which IPC section are the crimes registered. But for this particular exercise, I'm only looking at a binary choice variable, whether these candidates have a criminal case, which is no, or they have criminal case, which is yes. This is the education declaration they have given. This candidate is, some of them are graduate, some of them have gone to some school, some of them have done postgraduate, undergraduate, at the various kind of education level which we have. And this is the total declared assets. This is in terms of rupees, which simply means that, if you look at this candidate number 8, the candidate number 8 has a postgraduate degree, has no criminal cases pending against him, and has an asset of 3.76 million rupees. So that's how the data is structured. Now, what we're interested in knowing is at this level a very simple exercise, which is what determines the vote share of a candidate. Are there some factors which we think that can explain that how much votes will a candidate get in terms of the percentage share of the total votes polled in that constituency? In other words, we are looking at trying to predict what determines a candidate is going to win an election or not. Now, we can think of various variables which can determine, but given that we have a constraint, these are the only set of data which we have, we will stick to only this set of data. The first thing we need to do when we are trying to run a regression is to see what are the variables of interest and what are the factors I think is going to explain the variable of interest. So for example, what are the variables of interest? The candidate vote percentage. This is my Y variable. Okay. What are the other factors which I think that can explain? Most of us might be following TV news or reading newspaper that there is probably an increasing percentage of criminals elected in the assembly or the parliament. So criminal cases, having somebody criminal cases or not against them could be one variable of interest. The second variable of interest could be how educated the candidate is. The third could be how rich is the candidate. The fourth could be, is it the case that the party, if the candidate is from a recognized political party or is he one of the independent political parties or as an independent candidate? So these are the set of variables which we can think of. You can try some more variables from this particular exercise and see which explains or predicts better, but I'm going to stick to only this set of variables which I have talked about. Now, out of the variables, this is already in numeric. It's a continuous kind of variable. All possible values are possible, all the way from 0 to all the way technically to 100%. We can have values out here, and that's why this is a continuous variable. In terms of the x variables, the criminal cases are not quantitative variables as of now, they're qualitative, yes or no. So the first thing is we have to convert them to yes, these yes and no's to dichotomous variables as ones and zeros. The education, we can again use multiple conversion rule. For example, I can use a simple 1-0 where 1 indicates whether the candidate is graduate or above and 0 indicates that the candidate is not graduate. Which is to say, if I had used that variable, these two candidates will get values of 1 and 1, whereas these candidates will not get values 1, they will be given values of 0. Postgraduate candidate will get a value of 1, the undergraduate candidates will get 0 against that particular variable. Total assets is simpler, it's again a continuous variable, all possible values are possible, and therefore we can keep it that way. From the master data, let's look at what else can we do. So first we need to convert some of these variables which are qualitative to quantitative. So what were the variables of interest which I had spoken about earlier? The candidate vote, which is Y. I don't have to do anything. I have to code whether the party is a national recognized party or regional recognized party. So every time the candidate is from a party which is a national party, I give a value of 1 against him and 0 otherwise. And if the party is one of the regional parties, then I give a value of 1 and 0 otherwise. So to see how the data works, let's just focus on these three candidates. The candidate number 1, he is from Bahujan Samaj Party, which is a national party, therefore he gets the value of 1 here and gets nothing in terms of the regional parties. We look at the second candidate, he is from RSP, that's a state level party, so it gets 0 for the national party and 1 for the regional party. The third person is from a party RDP. It is neither a national party nor a regional party and therefore it gets 0 in both cases. So what you actually have is a grid where you get some 1s here and some 1s here, some zeros, and there will be some entries where both of them are 0. Okay. So that's the step 1 when we have coded this. We are going to follow the same rule to also code the others. In particular, I'm going to put zeros and ones against criminal. Anybody who has a criminal record will have a 1, others will have 0. I simply code the education as if you are a graduate and above, you get 1, and if you're not, then you get 0. The total assets, I just keep it that way. But this is what we often need to do while we are doing a regression. So we need to ask ourselves that when I am looking at what determines a candidate winning an election, so the voters are looking at that particular candidate. The voters are comparing that candidate vis-a-vis his peers. That is who others, all the others who are competing from that constituency, and then deciding whom to vote. That is to say, if the voter finds a particular candidate extremely rich in his constituency, he is not going to evaluate, or more likely not going to evaluate, this candidate vis-a-vis candidates in some other constituencies, because that might simply not interest the voters. So the voters are comparing the candidates within its constituency and not across constituencies. So therefore, to have the total assets could be important, but perhaps what is more important is how are the candidates ranked among themselves in terms of the total assets. Which means if there is a constituency which has 10 candidates all fighting for the election, what is of more interest to the voter is who among them is the richest, who among them is the second, who among them is the third, and not so much as how much money these candidates have. So this new variable asset rank is not what is which this was not existing in the original sets of variable, but these are what we call the proxy variables we create to measure the impact of something. So if I am trying to measure the impact of whether money helps an individual winning the election, I am trying to do that by constructing a variable which is called an asset rank, where the rank is you are ranking those candidates within a constituency, okay, and ranking them in whatever order, 1, 2, 3, 4. So if we are looking at, let's say, the first constituency where I am blocking it, which is happens to be Alipurduar. Okay, there are 11 candidates here, and the way the candidates are ranked is this is the candidate who has the highest wealth, 1, 2. This is the candidate with the second highest wealth, and that's how it's ranked. We will try and see that maybe this explains the chance of winning an election more than just the total asset value. So now that we have done this, the next thing we need to do is we may want to just do a few simple scatter plots to see how will the eventual regression look like, or it might more importantly give us an idea what do we expect. For example, do we expect that candidates who have higher income or more or richer in a constituency more likely to win or get more votes than candidates who are lower in rank in terms of income? Putting in other words, if we pick up constituencies in general, which of the candidates are more likely to get higher votes? The ones who are ranked 1, 2, 3, they're the richest candidates in the constituency? Or is it the case that the candidates who are ranked bottom, those who are 8, 9, 10, they are more likely to get higher votes? Perhaps even before doing the regression equation, we may have an expectation. My guess would be that higher is the rank, that is if you're 1, 2, 3, more chances of getting higher votes. So let's just simply do this plot. Okay, so now when I'm trying to do this plot, I've just picked up some of the variables. I've just picked up rank and F candidate votes, and all I'm going to do right now is going to do a simple plot. So I have selected this, and if I were to do a simple scatter plot, this is what we are going to get. So these are the ranks. So 0 to 15 are the ranks, and these are the percentage vote. And we find out that this is actually going down, which means people who have lower, whose ranks are 1 or 2 or 3, who are the richer ones, they are more likely to get higher percentage of vote. If you move to people who have lower wealth vis-a-vis others. Remember, higher rank means, higher is the number on the ranking scale, poorer you are. So richer is the candidate, more likely you are going to receive higher percentage of vote. Poorer is the candidate, which means as you are moving on this side, you are likely to get lesser percentage of vote. So in a way, what it means is a very clear pattern that when voters evaluate candidates in a constituency, it is more likely that the candidates who are richer in the peer group are more likely to win the election because they are more likely to get the higher votes. So that's how that is one of the reasons we do various kinds of scatter plots to get some initial idea, and then we move on straight to doing the regression and looking at the interpretation.